Analyzing section throughput using AI-powered precise train traffic control. As of now, the current issues are station masters often rely on phone calls with the nearby station masters whether a train is approaching or crossed a section, and this causes delays and sometimes leads to inaccurate decisions. And let's consider another scenario where multiple trains are approaching a station and the station master needs to decide which train to get the business manually. And this may be inconsistent sometimes. And if one train is delayed with any reason, other trains need to be rescheduled manually. So to overcome all these problems, we have came up with a solution which is hybrid based and consists of rule based and reinforcement. In this, every controller will be having a dashboard like this for their respective station, and the UI will be same for this, and they will be also having the information of the station left to it and the station right to it. Let the stations be Vishakhapatnam, Simhachalam and Pendutti for here. So coming to the current station, which is Simhachalam here, they'll be having the information. Firstly, track status. You can see here track 1 and 2 are red in color. That means those tracks are fully occupied, and the remaining are yellow in color. That means those tracks are empty. And AI will be giving priority for the trains based on the trains which are in the current station and the trains which are in the station left to it and right to it. So you can see here uh, the trains present in Simhachalam are Howrah Mail and Sirkar Express. So in these both, Howrah Mail is given highest priority and next Sirkar Express is given medium priority. And this AI will be giving priority along with the reasoning by the priority need to be considered. So you can see the reason why Howrah Mail is given highest priority. So AI will be giving priority based on this. And next, we'll be having the platform status. You can see here track 1 and 2 are in platform 1 and these both are occupied. So these are in the red color. And platform 2 and 3 having all the tracks in yellow. So it means all the tracks are empty. So platform 2 and 3 are empty. In left of this, you can find the trains list which are coming from Vishakhapatnam to Pendutti. And in the right, you can find trains which are coming from Pendutti to Vishakhapatnam. And for Howrah Mail, you can see that here plus 5M it in red color. That means Howrah Mail train is delayed for 5 minutes. So it is shown in the red color. And next, every priority given by AI is based on a score system. That means each priority is awarded with a score. So and the priority is given. So it is useful that station masters can give decisions based on this. If you want to apply decision, you can click on this. And next, station masters can't test how decisions will impact downstream sections. So we have what if simulation and scenario analysis option so that station masters can know what would happen if there is any scenario. So let us consider if there is rush on a particular day. Let's see how it works. So I'm entering rush and the track availabilities are like track 5246 and I'll be running the simulation. So if there is rush on a particular day in Vishakhapatnam station and the track availabilities are this, we'll be having this like throughput would be 16 trains per hour and total delay would be 27 minutes. So a wrong decision can cause a chain reaction of delays. So to overcome all these, our model will suggest. So let us consider another scenario. Let it be a train be delayed and I am running the simulation. So for delay, this is how the scenario would be. So to overcome any scenario, our model will suggest what to do. And that means our model will be recommending. And we'll also have an option to compare scenarios. For this, we need to click on this. And when you go to compare scenarios, you can find information like for delay and for rush. And similarly, total delay compression, for that delay has total delay 23 and rush has total delay 27. So this is about the what if simulation and scenario analysis. And if there are any train delays due to any reason, like the issues would be like train repair, signal maintenance, overhead, wire work, and any of the mentioned, and I'm selecting platform work, and the time required to call this issue be 2 hours, and the affected track numbers would be 3. So now I want to schedule all the train timings and update it because I have an issue. So you can see here, based on this issue, all the trains have been scheduled. And next, we can also have the real-time analytics in this option. So you can see here total trains are 52, active delays 3. So these are all the real-time information presenting here. And if you can also select the data range, I'm selecting only for September 20 to 28. And sections are Vishakhapatnam to Simhachalam. And then this is the real-time analytics in the data range and for that particular section. We can also see signal status distribution and also platform utilization rate too. You can see Vishakhapatnam has utilized 78% of its platforms, and similarly Simhachalam and Pendutti. And internet is unreliable in many sections, and if connectivity is lost, decision making will be stopped by AI. So for this, we have came up with an option for offline mode, like the controllers need to enter the data manually and then AI will be generating the priority. So let's see how it works. I'm entering some information of trains. Delay will be 2 minutes and remaining stops are 1 for this. And similarly for Pendutti, come on. And the delay, there is no delay for this train. And the remaining stops are 3. And now I want to generate the priority. So you can see here, even in offline mode, you can enter the data manually and get priority recommendations by AI. And after getting into online, it automatically goes to online. And the controller can see the information of the stations left and right to it. So see about Vishakhapatnam, you can see that number of platforms are 8, number of tracks are 12 and occupied are 5 and 7 are available. And these are the trains currently at Vishakhapatnam, as you can see here. And these are the track statuses, whether you can see that platform 1, track 1, this has been occupied and track 2 is empty. And similarly, AI model predicts and give recommendations for all stations, and we can also see here. And similarly, for the station right to it and Pendutti here, these are the trains currently at Pendutti, and the platforms are 3, tracks are 4, in which 2 are occupied and 2 are available. And track status and AI model priority predictions. So this is how our hybrid rail flow model works.